Hi, welcome to StatStuff. I'm Matt Hansen. In this lesson, we'll pull together a lot of the various topics about distribution, central tendency, and spread by showing you how you can easily calculate all of those using a graphical summary in Minitab. So let's begin by quickly reviewing how spread and central tendency are the characteristics that describe a distribution.
Well, if you recall, we said that the shape of the distribution is influenced by two different characteristics. So if we have an example here of three distributions that are laid out on a scale, the first characteristic is central tendency. This is where it's referring to the location on the scale where the majority of the data points are concentrated or where they're more centralized. It's that central point where the data tends to fall, where most of those data points tend to fall like this on the scale. And for normal distributions, again, it's the mean or the average that we would tend to use for measuring that central tendency. The other characteristic is variation or spread. This is referring again to how dispersed or spread out the data is from the central tendency. So for each of these distributions, they all have varying degrees on how far spread out they are. Even though they all have the same central tendency, they are all different in how spread out they are from that central tendency. And usually for normal distributions, it'll be the standard deviation that's going to be our measurement for spread or variation.
Okay, now let's compare some distributions to show you how central tendency and spread describe them differently.
Well, again, since the mean and standard deviation are used for describing the shape of a normal distribution, we can say as we compare these different types of distributions, it really depends on what that mean and standard deviation is. So in the first example, we'll see that here we have two distributions, again, both of these being normal. Here we have two different means, but it appears we have the same standard deviation. So the actual shape of the bell curve itself in each one of these, the distribution between each one, the variation between each one looks about to be the same between each. However, because there's a difference in the central tendency represented by the dotted lines on here, then that's really the only thing that's different, the mean within each one. Another example would be where we have two distributions who have the same mean this time, but different standard deviations. Different standard deviations, again, because the blue one has more of a peak here, so there's less variation, versus the red distribution has more plateaued in its shape. So because of that, it's more dispersed and it's more spread out from the central tendency, so it has a much larger standard deviation. Now in this last case, for the third example, here we have two different means and two different standard deviations between each one because they're both shifted in the central tendency between each distribution, and the actual shape of the bell curve itself representing the spread or dispersion of each of the data points around the mean are also very different between them.
Now let's pull all this together by looking at a graphical summary in Minitab.
The Graphical Summary is one of my favorite tools to actually work with from within Minitab when I start to work with my data. It gives me a good visual as well as all the necessary descriptive statistics related to the data that I'm looking at. And the example I'm going to show you now is what's built within Minitab and how you can build this same Graphical Summary in Minitab. But obviously Minitab is not the only tool that can give you this type of information, but these examples I'll show you are typically what you can use if you happen to be using Minitab as your source. So if you're going to be using Minitab for this, then you would go to the Stat menu, Basic Statistics, and then Graphical Summary. And then what's going to present to you is this dialog box. Within this dialog box, what's going to give you are all your fields within your data, but it's only going to display the fields that actually have continuous data. So you have to make sure when you select within this first one here, variables, that has to be some continuous value that's in your data set. Now, we've talked about in the past, you have discrete values. You can actually represent your discrete values as continuous, as a numerical value, and Minitab really won't know the difference. So if you have, for example, if you're doing something that is true false and you represent it as a 1 or a 0 in your data set, Minitab's going to think that it's continuous data without realizing that your actual data set is only limited to just the 1 and the 0. They're really treated as discrete values. So it will show you that field in here. I would strongly caution you though, do not use that. It's not intended to be used as a continuous value, so just be careful. Even though it's displayed in here, it doesn't mean it's appropriate for using that as part of your analysis, not only in the graphical summary because it really won't be meaningful anyway, but even for future analysis. Just be sure that when you're using a continuous value, that's truly a continuous value and not a discrete value that's been forced to appear like a continuous value. So in this case, when you select variables, this is where you're going to be selecting, again, one of these truly continuous values in here, probably like your project Y, that output that you're trying to measure. Also, you can have this section that says by variables. You don't need this, it's optional. However, what you might want to do is you might want to have your data, your whole data set split between some discrete value or split between something else. And this would be ideal when you want to split your data across some discrete values. And if you do that, you click in here, it's going to give you more of your discrete fields of data available for you to choose from. So what it will do is it will split your data across all the different available types that are within that discrete field that you've selected, and it'll split that. So for example, if you have again a 1 or a 0 or true or false as part of your discrete values, then it's going to split your data and it's going to create a graphical summary, one for the true and one for the false. Or if you happen to have something else, like if you happen to use a Likert scale for a survey, you want to split the data across all the different options that you had as a result of your Likert scale. Well then, if you had 5 options in your Likert scale and there's 5 different options or discrete values, unique discrete values that are within your data set for a particular field, then it's going to create 5 different graphical summaries. So just be aware, you probably do not want to include a continuous value in here, because again, the idea behind having a continuous value is you have a whole lot of values, and because it's intended as a continuous value to imply that it can go on to infinity, or it could be infinitely divisible. As a result, you'd have a whole variety of values that could be represented there. So just be very careful. If you select a continuous value and you do have a large variety of variables within that particular field you select, then you're going to have that many unique graphical summaries are going to be created. So just be very careful. You probably want to use a discrete value in there. So by doing that, you select OK, and it's going to create this example of a graphical summary. It's going to take that data and it's going to plot and create this distribution here. It's going to try to fit a bell curve on top of that so you can see how it fits. And then what you're going to have is the visual here on the left-hand side. On the right-hand side, you're going to have some more of those descriptive statistics. So at the top here, you're going to start off with the normality test. So right away, we can determine from here if the data is normal. In this case, like we've done on the examination of using a normality test, if the p-value happens to be, in our case, if we're using an alpha risk of 5%, which means we want 95% confidence, well then that means we look for a p-value that is greater than 5% if it's going to be normal. In this case, since our p-value here shows 20%, that's greater than our 5% risk, then I can be confident, or at least more than 95% confident, that this is a normal distribution. And next, we've got this next set of descriptive statistics here, which include the mean, the standard deviation, the variance, skewness, kurtosis, and n referring to the number of variables. So these are some really helpful things that help describe the shape, or again, back to the central tendency and back to the variance or spread that we might see within our distribution itself. Next section we have are some of the other elements, like the minimum and maximum we have here. And again, if you just subtract the minimum from the maximum, you got the range. And you also have some inner elements like the 20th percentile, which is the first quartile, 25th percentile, and that's the first quartile. Or you've got the median, which is the 50th percentile, and then you've got the third quartile represented by the 75th percentile. And again, you can use these values in here if you want to calculate the stability factor, which is Q1 divided by Q3, or if you want to calculate the interquartile range, which is Q3 subtracting Q1, or however you might want to use it. If you happen to have a non-normal distribution, at least you have all these values available to you in order to easily calculate that for yourself. And then beneath that, we've got automatically the calculation for us of the confidence intervals, where it gives us the 95% confidence interval for the mean, and then the median and the standard deviation. And it represents a lot of these values over in the graphical summary. Again, we've got the histogram here representing the distribution for all of our data, and then underneath of that we have a box plot where, again, like a typical box plot, we've got the inner line within the box representing our median value, and then the left line representing the first quartile, and the far right end of it representing the 75th percentile or the third quartile. And then we have the other elements within the first, or less than 25% or greater than 75%, drawn as a line off of either end of the box plot. And then beneath that, we've got the illustration of the confidence intervals themselves. So this way we can see when we're comparing the mean and median, we'd expect that if it's a normal distribution, that the mean and median would be about the same. And in this case, because there's so much overlap between the mean and median, the confidence intervals with each, then that's what we would normally expect to see in a normal distribution. However, if it's non-normal, and our distribution, chances are our mean and median is not going to have this much overlap between them within our confidence intervals, because something would have caused the mean to shift in one way or another because it's being skewed, or there's some outlier that's dragging it to one direction or another, again causing it to be non-normal. So to me, again, this is a great picture. One of the first things I tend to pull up when I want to do analysis on a particular data set, and I pull this up for certain values because this is a great visual for me to see all the data that I need necessary at one quick glance like this. I can see it visually as well as have all the descriptive statistics necessary in order to do some of this quick assessment of the data.
All right, before we close this lesson, let's discuss how we can apply some of these concepts in a practical way.
Well, if you have Minitab, I would challenge you to identify at least 3 different metrics that you use in an organization that are based off of continuous values. Again, those numerical type of values. And for each of those, try pulling some historical data and try to run a graphical summary on each of those different values. And after doing that, try to answer these next few questions based off of that graphical summary that you created on each one. First of all, is the data normal or non-normal? And what is it within the graphical summary is telling you that? Also, is the data multimodal? That is there more than one mode? We've talked about it before as like a bimodal or multimodal. There's multiple humps within your data. Or what's the central tendency for each metric? Is it going to be the mean or the median, and what's helping you determine which one to use? And what is that value for the mean or the median, or whichever one you're tending to use here? And also, what is the spread or the variation for each metric? And again, what's telling you which one you want to use? Are you going to be using the standard deviation? Are you going to be using the stability factor? And how is it that you calculate each one of those?
Well, that wraps up this lesson. Check out StatStuff.com for many more resources that can help you achieve powerful results. I'm Matt Hansen. Thanks for watching.